In this video, I will be explaining stoichiometric calculations, including mass, yield percent, and even some questions based on limiting and excess reagent. So let's begin with the first question. Whenever a question is given, you first read it and frame the equation. It says you made 750 grams of iron 3 oxide, and how much iron did you need to make this? That means iron is getting converted to iron oxide. So we will first write the equation, that is Fe. It's made to react with oxygen and it results in the formation of iron 3 oxide. So iron 3 oxide means the formula is Fe2O3. Right? Oxygen is 2 minus, Fe is 3 plus. So when you crisscross it, you will get it as Fe2O3. After you write the equation, you balance it. Right? So to balance it, you can just put 2 here. When you balance, this becomes 3 and this is 2. See, iron is 4. 4 this side. This is 3 into 2, 6. This is 2 into 3, 6. Right? Now, mass of iron oxide is given and mass of iron is to be calculated. That means in this, what conversions are required? Just keep this in mind. So it is basically grams of iron oxide, that is Fe2O3, is first to be converted into moles. Mole of Fe2O3, right? And then the mole of Fe2O3 is to be converted into mole of Fe. Thereafter, the mole of Fe is to be converted into grams of Fe. This is the conversion required. Whatever weight they have given, first we have to convert iron oxide into mole, and then mole of iron oxide to mole of Fe, and then grams of Fe. So this is how we are going to solve. Just see. So 750 grams they have given. So it is 750 grams of Fe2O3 divided by 1. This is always by 1. Now this is to be converted into mole. Normally, you just remember, how do you convert the mass to mole? Given weight by molar mass. Right? So what we can do is, molar mass of Fe2O3 has to be down. So what is the molar mass of Fe2O3? It is 159.69. So this much gram of Fe2O3, this will be in the denominator. This is 1 mole of Fe2O3. So 1 mole of Fe2O3 in the numerator divided by this. In a way, this weight we have divided by the molar mass to be converted into mole. Now, to convert this iron oxide to the mole of Fe, this is the one step we have done. So in this first one, total there are 3 steps. Step 1, this is the step 2, and this one is step 3. Right, so step 1 is done. So now we move on to step 2. This is the step 2. So how do we convert into mole of Fe? So we need to compare, the mole ratio we have to check. So 4 mole of Fe is obtained, 4 mole of Fe is used, and 2 mole of Fe2O3 is, formed. So since we are calculating Fe, so that Fe we will write down in the numerator. So it is 4 mole of Fe divided by 2 moles of Fe2O3. They are in this ratio, 4 and 2. That is the coefficients we are using. So now the second step is done. We have converted into mole of Fe. We move on to the third step. To convert the answer in grams, we have to convert whatever moles you get. You have to multiply by the molar mass of Fe. So what is the molar mass of Fe? That is 55.85 grams of Fe by, you have here as 1 mole of Fe. Right? Now after you do this, just make sure you are able to cancel most of the things but for one, in which we want the answer. See, gram of Fe with Fe2O3 with gram of Fe2O3. Then mole of Fe2O3 with the mole of Fe2O3. Then mole of Fe with mole of Fe. So what we are left over with? Only grams. So when you solve this, that means 750 into 4 into 55.85 divided by 59.69 into 2. right? So when you solve this, so you will get the answer here as here you get the answer as 524.61 grams. This is the answer you will get. Clear? Yeah. Now we'll move on to the next question. The question says that you are going to run a reaction to make ammonia from its elements. That means you are preparing ammonia, you are preparing NH3 from its elements. So what are the elements included in it? Nitrogen and hydrogen. And you balance it. After writing the equation, the first step is always balance it. You balance it. Without balancing, if you start, that is not the right way. Your answer will be wrong. And now they are saying how much of nitrogen is to be, nitrogen we are calculating and the given weight is for ammonia. So same way, grams of ammonia, from grams of ammonia we are trying to calculate the grams of nitrogen. Again, that means you have to follow 3 steps. So what are the steps in this? First, gram of ammonia you have to convert into moles of ammonia. After that, comparing the molar ratio, you have to convert it into mole of nitrogen. Then after mole of nitrogen, you have to convert into gram of nitrogen. Now just see, even in this, there are 3 steps. This is step 1, 2 and 3. Right? So how are we going to proceed? The same manner. What mass is given? You write down that. 147 grams of ammonia. Right? This is by 1. Then this we have to convert into mole of ammonia. Normally we divide this mass by molar mass, and the molar mass of ammonia is 17 grams. You will write down in the denominator 17 grams of ammonia and in the numerator 1 mole of ammonia. That is 1 mole of ammonia by 17. So in a way we have divided this given weight by molar mass to convert into moles. So one step is done. Now convert this ammonia moles into nitrogen moles. So we have to compare now moles of nitrogen and ammonia. We are calculating for nitrogen, so nitrogen moles will be in the numerator. This is 1 mole of nitrogen and the coefficient is 2 mole of ammonia. That means we will write 1 mole of nitrogen divided by, you will have here 2 moles of ammonia. So our second step is done. That is, we have converted the answer in moles of nitrogen. Now we want the answer in grams of nitrogen. Right? We want the answer in grams of nitrogen. So we'll convert into mass of nitrogen. So mass of nitrogen, what is the molar mass of nitrogen? 28. So that you will write down here. This is 28 grams of nitrogen is 1 mole of nitrogen. So now we will cancel out and see, are we able to do? This is grams of ammonia, grams of ammonia. Mole of ammonia, mole of ammonia. Mole of nitrogen, mole of nitrogen. So you are left over with the grams, right? So when you solve it, 147 into 28 divided by this into this 34. That means you will get the answer as 121.058. This much grams. So this is the answer. So the answer for the first one was this, and the answer for the second one is this. Got it? This is the second question. Now moving on to question number 3. You will add 18 liters of iodine to some hydrogen so as to get hydroiodic acid. That means you are aiming to prepare HI from hydrogen and iodine. So you will write down the equation. Read question thoroughly and then write the equation. And when you balance it, you will get this as 2. You are asked to calculate the mass of this and given as iodine. Iodine volume is given instead of the normal mass given. So it's not at all an issue. How do you convert this volume into moles? You have to divide by 22.4 liters. Okay, so again, first let us see what are the steps involved in it. Yeah, instead of grams here, this is the only difference. Instead of gram, they have given volume. So this is volume of iodine. First, you will be converting into moles of iodine. Thereafter, you will be converting the mole of iodine by comparing the molar ratio into mole of HI. Then you will be converting this into grams of HI. Okay, grams of HI, right? So, moving on to the calculation part. So, what we are doing? We started with this iodine. So, we will use this iodine first. Whatever is given first, you take it. 18 liters. 18 liters of iodine by 1. That is, first is always by 1. How do you convert the given volume into moles? You will divide this by 22.4 liters. That is a normal standard one. So this much liters of iodine, and this is what? This is 1 mole of iodine. See, every time we have been taking 1 mole by mass, 1 mole by, here it is 1 mole by volume. Why? Because we have used here volume. This is the first step done. Moving on to the second step. Mole of iodine to mole of HI. Mole of HI, that means we have to compare their molar ratios. We are calculating for HI, so its moles will be in the numerator. So you will have 2 mole of HI divided by, you will have this as 1 mole of I2. Right? 2 mole of HI by 1 mole of I2. Because that is the coefficient given. 2 and this is 1 given. And now you are expected to convert this into grams. So what is the molar mass of HI? With that you have to multiply. So it's 128 gram. 128 grams of HI by 1 mole of HI. 1 mole of HI. Now let's see what all things we can cancel out. See, it's liter of iodine, liter of iodine. Mole of iodine, mole of iodine. Mole of HI, mole of HI. We are left over with the grams only. So when you solve it, 18 into 2 into 128 divided by 22.4, you will be getting as 205.714, this much grams. This is your answer. So based upon whatever significant figures, in case they are asking, you can convert it accordingly. Okay, so at present I am just focusing upon how are you solving it. Moving on to the next question. 6 grams potassium iodide reacts with 7 grams lead nitrate and 2 products are obtained. You are asked to calculate what is excess in limiting reagent and how much is left over of excess reagent. So we will write equation first. That is potassium iodide plus you have lead nitrate, and it forms lead iodide plus potassium nitrate, right? Balance it. You just see iodine is twice, nitrate is twice. So you have to keep that in mind and do it. Okay, so when you do it, nitrate is already twice, so let's put 2 here. When you put 2 here, nitrate becomes twice, that is balanced. Lead is not to be touched. Iodine and potassium, so this 2 has to come. Right? Now, what are they asking us? Limiting or excess. So that means we will first find out 6 grams of Ki requires how much of lead nitrate and 7 requires how much of potassium iodide. Means we are going to decide first which is the limiting reagent. So first let us take potassium iodide. 6 gram potassium iodide will require how much of lead nitrate. So you go by the normal method, as you say, the grams of potassium iodide, that is 6, that is only better. 6 grams potassium iodide by 1 always you take. Convert this weight into molar mass, moles. Divide that by molar mass, that is 166 grams of potassium iodide. That is 1 mole of potassium iodide, right? Now, the first step is done. We have converted the weight into moles. Now we have to convert this moles of potassium iodide into how many moles of lead nitrate? Comparing their molar ratio. What are we calculating for lead nitrate? So for lead nitrate, what is the coefficient? 1 mole. So we will say 1 mole of lead nitrate. 1 mole of lead nitrate divided by, what is the coefficient for potassium iodide? 2 moles. So that is 2 moles of potassium iodide. And then how much mass of lead nitrate? That means we need the molar mass. Lead nitrate molar mass is 331.2 grams. So this much gram of lead nitrate, I'm just writing Ln for lead nitrate because of lack of space, divided by 1 mole of lead nitrate. We will cancel out what all we can. Okay, the like terms, grams of potassium iodide with grams, moles of Ki with moles, moles of lead nitrate with the moles. So what all we are left over with, we are going to solve, like how much is used, right? How much of the 6 gram of potassium iodide will require how much of lead nitrate. So we are going to solve this with it. So you get the answer as 5.96 gram. We require only this much. We require only this much of lead nitrate. But how much are you having? You are having 7 gram. So actually your game is over here. You know that 6 gram requires only 7, but you are having 7 grams. So that means this is the excess reagent, this is the limiting. But nevertheless, you can just verify it once again. By using 7 gram of lead nitrate will require how much of potassium iodide? Let's calculate that part. Right? So for that, what you have? 7 grams of lead nitrate by 1 into, convert this into moles, divide by molar mass. So molar mass of lead nitrate is 131.2. This much grams of lead nitrate is 1 mole of lead nitrate, that in the numerator, multiplied by, one step is over, convert this moles into potassium iodide moles. So we are calculating for potassium iodide, so its moles will be in the numerator. 2 moles of potassium iodide divided by how many moles of lead nitrate? 1. So you will have 1 mole of lead nitrate. Check the mass of lead nitrate. Molar mass of lead nitrate is 166. So we'll convert that, whatever grams of potassium iodide will be required for 7 grams. So this much gram of potassium iodide by 1 mole of Ki. Right? So cancel out what all you can. Grams of lead nitrate with grams, moles with moles, moles of Ki with moles of Ki. So when you solve this 7 into this divided by 331 point something, you get the answer as 7.012, this much gram. That means to react with 6 gram of potassium iodide, you require this much of lead nitrate, but you are having 7. That means lead nitrate is your excess reagent. And if you use 7 grams of lead nitrate, it's enough. This requires 7 point something grams of potassium iodide, but you are having only 6. That means this is your limiting reagent. So this is done, this is done. What is excess? This is your limiting reagent, right? This is your limiting. So 6 requires how much only? It requires just 5.96 grams of lead nitrate. But how much we are having? 7. So that's 7 minus 5.96 grams. Right? Whatever is your answer here, that much will be the excess reagent. So your excess reagent is 1.04 grams of lead nitrate. This is excess. This is your excess reagent. Got it? Your limiting reagent is Ki, excess reagent is lead nitrate, and how much excess? This much excess. Okay? Now, we move on to the next question, that is 50 grams of hydrogen peroxide. So let's write the equation first. Hydrogen peroxide is undergoing decomposition and forming water plus oxygen. Balance the equation. First you go for this is odd number, you put it as 2 and 2. That's it. Your equation is balanced. You are collecting this much gram of oxygen. They are asking you actual yield, theoretical yield and percent yield. Right? So first let us see what is the theoretical yield. What is the theoretical yield? Okay. Let's see. 50 grams we have taken, right? The first grams into moles. The same 3 steps we have to use. So you will have 50 grams of hydrogen peroxide by 1. This much gram of hydrogen peroxide is first to be converted to moles of hydrogen peroxide. Given weight by molecular weight. So molecular weight of hydrogen peroxide is 34. This much gram of hydrogen peroxide is 1 mole of O2. We have converted this into mole of hydrogen peroxide. Right? Into. We will find out how many moles of oxygen will be obtained by 50 grams. So what are we calculating? Oxygen. So oxygen moles will be in the numerator. What are the coefficients? Molar ratios you are going to compare. 1 mole of oxygen is 2 moles of hydrogen peroxide. Right? Now we will find out the mass of oxygen obtained. What is the molar mass of oxygen? 32 grams. So 32 grams of oxygen is 1 mole. We are going to calculate this part first. Cancel out. If they are not getting cancelled means you are going wrong somewhere. Okay. So this gram of H2O2, mole of H2O2, mole of O2. This is mole of O2. Yeah. So when you solve this, you will get it around 23.529 grams. This much grams of oxygen is obtained. Okay, this is your theoretical yield. This is your theoretical yield. How much is your actual yield? This much. So you have to calculate, this thing, percent yield. So what is your percent yield? Percent yield is actual yield divided by theoretical yield. Theoretical yield into 100. Right? So how much is your actual yield? 12.1, which is given in the question, divided by, this is your theoretical yield, 23.529 into 100. Okay? So answer here comes out to be 51.42%. This much percent is your percent yield. Right? Theoretical yield is this one. Actual yield was given. Percent is this. Right? Yeah. Now moving on to the next one, which is actually a continuation of the previous question. The question says, with reference to the first one, you want to collect 75 grams of oxygen from the previous experiment. Right? Which will have the same percent yield, and how much hydrogen peroxide will you need. Okay, so let's go ahead with this. 75 grams of oxygen. So 75 grams of oxygen by 1 first. Convert this into moles. So it is divided by molar mass. You're having the molar mass of oxygen 32. Yeah, 32 grams of oxygen, and it is 1 mole of oxygen. Right? Convert this into this will be given by how much of hydrogen peroxide. Right? Compare the molar ratios. So molar, this we are calculating. So it will be in the numerator, 2 moles of hydrogen peroxide divided by 1 mole of oxygen. Right? So just check the coefficient 2 and 1. Whatever you are calculating in the numerator, the other one in the denominator. Now we have to convert this moles of H2O2 into mass. That is 34 molar mass of hydrogen peroxide. So 34 grams of hydrogen peroxide is 1 mole of hydrogen peroxide. You can check, you can cancel out grams with this, mole of O2 with mole of this with this. And when you solve it, you will get it as 159.375 grams. That means this much gram of hydrogen peroxide is required. This is this part of the question. How much of hydrogen peroxide will you need? This much you will require. Plus, they are saying which will have the same percent yield. That means whatever you are getting with this 159 grams, 159 point whatever grams of hydrogen peroxide, with this hydrogen peroxide you will be getting approximately same quantity of the oxygen. Okay, so please go through whatever questions we have discussed. Okay, that's all for today. For more confidence, please practice more numericals on stoichiometric calculations. Thank you.